Lesson 16.4, analyzing integrally defined functions with equations, which I actually almost think is easier than the graphs. It says, given the function f of x, terminal intervals on which f is decreasing. I think it's easier because you don't have to worry about f and g, and they've already got it written for you. So thinking about where this function would be decreasing means that its slopes have to be negative values or less than 0. So I would want to take the derivative of f of x, which means take the derivative of the integral. I'm not even going to worry about doing the bounds. And a derivative and an integral cancel each other out. So f prime of x really just equals, now we're going to replace these with x's, x to the 4th minus 4x squared. I want to find the critical points, which is where we set this equal to 0. And then we solve by factoring. I can take out an x squared from both terms. That would be times x squared minus 4, which is a difference of squares here, but I'm going to go ahead and solve. Let me bring it up here. This would get x is 0. It has a multiplicity of 2, which is going to be important. This, I would add 4, square root 4, which gets me positive and negative 2. When you square, you get two answers. You can also think of this as a difference of squares, which would be x plus 2 times x minus 2, and you could clearly see that it gets positive and negative 2. So let's make a number line. Put our values from least to greatest, so a negative 2, and then it would be 0, and then it would be 2. We're using this as a sign chart to plug in values. So what we used to do is say, okay, let's start from the right and pick a number bigger than 2 is 3. If I were to plug it in here, I would have 3 squared is 9 minus 4, that's positive, times that would obviously be a positive, so this is positive. And then 2, find the answer to that, which is here. The multiplicity was just 1 because I only get one answer of 2. It came from having this x minus 2. So it would switch signs. At 0, its multiplicity was 2, so it's actually going to stay the same sign. And negative 2 had a multiplicity of 1. Something else I want to see if this helps with is thinking about end behavior. Going back to this function, looking at the highest degree x or degree term, it's x to the 4th and it's got a positive in front. That means that both ends will be pointing up. So then what it does is it crosses through, and then think about the bouncing. So at negative 2 it'll cross. At 0 it'll bounce because it was a multiplicity of 2. And then at 2 it'll cross. So it makes this W shape. That helps me as well. But what I was trying to figure out is where was this decreasing? Well, it decreases anywhere where the y's are negative, which is happening between negative 2 and 2. Okay, number 2. Given the function, determine all x values for which f has a relative minimum. Again, thinking a minimum comes from something that's decreasing to increasing. So we want to figure out the slopes. So I'll take f prime of x. I'll take the derivative of this side, which makes this and this cancel, giving me just this function. I'm going to plug x in for t. And then I'm going to factor it. Take out an x cubed. Be x squared minus 25. Set equal to 0 to get the critical values. And solve. I don't need that. So that would be 0. Has an odd multiplicity. This would be square root of 25, which is plus and minus 5. Make your sign chart. Put your numbers in order, least to greatest. So looking at this, this is an odd function because it's x to the 5th power, which is odd. Odd functions have one end up, one end down. Looking at the leading coefficient being positive, the right end's up, the left end's down. And then going through negative 5, that should only be multiplicity of 1 because you only got that answer once. Then it'll be up. 0, it's going to cross because it's odd. Anytime the multiplicity is odd, it crosses. change direction, and then at 5 it should cross through. So you could do it that way if that helps you, or you could think, okay, if I plug in 6 squared is 36 minus 25, that's positive. If I plug in 4, or if I think about at 5 it crosses, it's going to switch, 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 however you want to do it. So where did it have a minimum? It had to go from negative to positive. So negative to positive would be happening here. Negative to positive would be happening here. So at negative 5 and 5. All right, number 3. Determining intervals in which f is concave down. So concave down actually comes from the second derivative. We want that to be negative. So if I take f prime of x and I derive this side, that's cancels, boop, boop. So that's x to the 5th plus 10x to the 4th plus 25x cubed. Then I want to derive again. Power rule says 5x to the 4th plus 40x cubed plus 75x squared. Okay, set that equal to 0, and we're just going to do the same thing we've been doing. Take out a 5x squared, so it'll be times x squared plus 8x plus, I think about that, is that 15? Okay, and then this is a basic trinomial that needs to get factored again. Two numbers that multiply to make 15 and add to make 8 is 5 and 3. Okay, so then my solutions, run out of room here, but I get a 0, the multiplicity of 2, negative 5, and negative 3. So now make your sign chart, put your numbers in order, be negative 5, negative 3, 0. I'm going to do end behavior again. So this is a 5x to the 4th. It's a positive and it's even, so both ends will end up going up. Through negative 5, it should cross. Negative 3, it should cross. And then at 0, it's going to bounce. Okay. So then where was this negative or below the x-axis is from negative 5 to negative 3. And the last one. We're trying to figure out where f has a point of inflection. Points of inflection are when the second derivative changes sign. So it's got to go from positive to negative or negative to positive. So you're going to do the same thing where you want to take the derivative of both sides. So f prime of x, the negative 2x cubed plus 24x squared minus 72x. Take the second derivative. Negative 2 times 3 is negative 6x squared plus 48x minus 72. Factor out a negative 6. It would be minus 8x, and that would be 12. Positive 12. Factor the trinomial again. That would be 2 negatives, and that would be, what, 6 and 2? Negative 6 is not going to have an answer because there's no x there. So you get answers of 6 and 2 for your critical points. Okay, looking at this is an x squared. It's an even function, but it's a negative leading coefficient. So both ends will be pointing down, and it's going to cross through. So it's going to cross and cross. So really it's just a quadratic that's flipped upside down. Where does it change sign? Well, it changes sign here. It goes from negative to positive, and from negative or positive to negative. So at 2 and 6 are its points of inflection.